Hi there, this is Kabul, and today we've got a special guest with us, Jonah.
Yay!
Hello, Jonah.
Hello.
So, Jonah, you're how old?
8.
8 years old. And what is it that you do for your living?
We do homeschool at the moment.
Oh, is that what you do for a living?
No, not for a living. I like coding.
You like coding?
Yeah.
Have you coded before?
A little bit.
Yeah, and what do you program in?
Scratch.
Scratch, okay. Anything else?
Not really.
No.
Well, Lego we do as well.
Lego we do. Okay, cool. So let's have a look then. So you've been homeschooling for a bit. You've been enjoying it?
Yeah, a little bit.
Just a little bit?
Yeah.
You're looking forward to going back to school?
Yeah.
Why only a little bit?
Looking forward to go back to school.
Yeah, but why are you only enjoying your homeschooling a little bit? Why not? You're enjoying it lots.
Because there's no friends.
Ah, there's no friends. Okay, so it's nothing to do with homeschooling with daddy or mummy then?
No.
Oh, okay then. Cool. So, yeah, so you've got this problem over here, which you've been sent by your teachers, is that right?
Yeah.
And have you solved this problem already? Have you?
Yeah.
Oh, you have? Okay, well, how did you do that?
I use trial and error.
Trial and error. Okay.
Yeah.
Well, do you want to tell me how you solve? So, what's the question first of all? So you've got 9 digits. Is that right? 1 through to 9.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah.
Yeah.
And each one of them must be different that you put in the box in each one of the boxes, and then you make 2 digits out of the numbers, so across and below. And you add all 4 numbers, and you've got to find different ways of making 100. Is that right?
Yeah.
And how did you go ahead and do that?
I just tried. I used trial and error, but I only found one way using that.
Okay. What were your numbers? Do you remember those?
8, 5, 3, 1. I think.
8, 5, 3, 1.
I think.
You think so? Okay, well, I'm gonna put you to the test and see if that works. Does that order matter? Which order it is in?
No, not the order.
The order doesn't matter.
Yeah, it could just be any.
Alright, okay, well, let's put that into a little table then. So if you're saying 8, 5, 3, 1. That's interesting that the order doesn't matter. So 8, 5, 3, 1. Is that right? You're telling me order doesn't matter, so across and below is how you do it. Is that right? 85 plus 31, that's already more than 100, isn't it?
Oh. Okay, not that.
No.
Probably that one at the top.
Yeah.
Then the bottom one. The bottom one.
That one?
No, the bottom one. The bottom one. Yeah, that one. That might be an 8.
That might be an 8, okay.
Let's try that.
So let's try that. So 13 add 58, do you know what that is?
13 add 58. That's 40. No, 50. 53.
58 add 13. 72?
It's probably. Oh, I swap the 5 for 1. I think that's one.
Swap the 5 and 1.
No, I mean.
How about we try that one?
Yeah, do that.
Oh, sorry, it was 5, wasn't it? So
yeah.
Try add those now. You've got to add those 2 numbers and those 2 numbers. Those 2 numbers and those 2 numbers. Does that give you a total of 100?
That gives you 71. 71.
Okay. Which way does it give you 71?
It gives you 71, 15, and 58.
Okay. Well, I think I'm going to cheat. I know what the answer is. One of the answers is. So here we go. So if we put this one over here as 2, this one over here as 1.
Oh, you got that.
And if I do 3 over here, so try that. So 23 add 18.
23 and 18 is 41. 41.
41. And that way, 21 add 38. 59.
Yeah.
So is the sum of all of those numbers 100?
20.
So you have 21,
Yeah.
add 38, add 23, and 18, isn't that right?
Yeah.
So that'll give you 100 then?
Let me see. Yeah, it does.
It does? Awesome. So that's one of our answers. So you kind of got there bumbling along with trial and error, right?
Yeah, kind of.
Which is good. Now, you know, maths is really easy to program, or at least it should be anyway. Can I tell you the process that you went through just now? Or what you would have done to find the answer for this?
Okay.
So what you would have done is put one of these numbers into there, put the other number into here, the other number into here, and 4 into the fourth column, or something along those lines. And what you would have done is, yeah, a bit like the one at the bottom. So what you would have done is just manually go ahead and add one. Add, change number, add, change number, add, change number, add, change number, add. So that is very algorithmic. It's not quite an, it's brute force. You're going through all the possible iterations and then saying this is what the this is what the answers are. Okay, so that's what we're going to try and do today. So you've heard of LabVIEW before?
Yeah.
Yeah. Where have you heard about it?
Oh, I just heard about it.
Yeah, where? From me?
Yeah.
Okay, well that's a bit of a cheating, isn't it?
You use it, so I think you use it a lot.
Okay, so I've got LabVIEW open here. It's the Community Edition 2020 LabVIEW. So what do you know about LabVIEW so far? It's a programming language, is that right? Cool. What makes it different from other programming languages?
They use lines.
They use lines.
I don't know.
Oh, okay. Well, that's a good place to start. So it's a graphical programming language, right? So have you worked with LabVIEW before?
No.
No. Okay. So there are two parts to the LabVIEW program. So have you worked with Scratch? You said, yeah.
Yeah.
So with Scratch, you've got the code area, and you've got the output area where you see the sprite moving around, or if it's your Lego WeDo, that's your output, and you see something happen. So in LabVIEW, you've kind of got something similar. So you've got the front panel, which is where you have your controls and indicators. So you can control things from there. You can see the outputs of something, of your calculations. And then in the block diagram is where your code goes. Okay, so let's say, for example, one of the variables in our program would be numbers. Yeah, so 1 through to 9. So we want 9 numbers altogether.
Yeah.
Okay, so I'm going to change the type of that to, don't worry about what I'm doing right now because it's just representation. Do you know what integers are?
Integers?
Whole numbers.
No. Oh, whole numbers.
Yeah, so without a fraction.
Oh, okay.
So that's what I've just changed that number into. So I can't type in a 9.9 on there. It'll just convert it to 10. So I'll just round it up to 10. Okay. So I want 9 numbers. Yeah.
So that's what rounding is used for.
Yeah.
Oh, okay.
Yeah, that's right. So in the functions palette, effectively, what we can do is say what kind of structure we want to use. Now, you know what a for loop is?
No.
Okay, a for loop is something that you run for a certain number of times. So if I was to say, Jonah, go brush your teeth, how many times do I need to say that, do you think, before you actually brush your teeth?
1.
No, I have not had you brush your teeth the first time I've asked you. So that's a for loop for me for about maybe 10 iterations. I've got to say it 10 times before something actually happens by you brushing your teeth. So a for loop, let's put that number in there. So a number of numbers, iteration. I want it to run 9 times. That's all I've got there. So I've got 9 there, and then I've got the for loop running. Okay. So that's simple. Let me just save this so we can come back to it later on as well. So coding challenge, school maths homework solutions, and this is part 1. Okay. So what we want to do is generate. Do you know what an array is?
Yeah, I think.
What do you think an array is?
Is it like 4 across and 4 down.
It could be any length across and any down. That's a 2-dimensional array, isn't it?
I don't know what a 3-dimensional array is.
3-dimensional array is what you see right now. So something that's got x, y, and depth.
Oh, so I remember arrays now. It's kind of like this, and it could be like that.
Yeah.
It could be like.
So do you see that now? I've got an array here with 1 dimension, so I can only have numbers in one direction. Now, if you think back to what our question was, that for me is a 1-dimensional array. Yeah. So that's what I'm trying to recreate first. So if I run that now, I just hit Control-R to run it. There you go. I've got my 9 numbers.
Yeah.
And the reason I have that is because I ran the for loop, and every for loop has got an iteration count.
Yeah.
I add iteration count first from 0, so I add 1 to it for my first number to be 1, and then I get a number out of it. Happy so far?
Yeah.
Awesome. So if I was to turn this to 12, what do you think would happen?
It'll go up to 12.
Voila. Cool. So here we go then. Let's leave that at 9, save that one, and I'm going to hit Control-U so I clean that up. Save that. I just realized we've not actually shown that. So that's what happens. So if we show that again, just for the people watching, there we go. If you change that to 12, you get 12, and you change it back to 9, you get 9. Okay, so that's our code so far. So here we have our block diagram, our code with a for loop. You've got our controls and indicators on our front panel.
Yeah.
Happy?
Yeah.
Awesome. So what we just said just now was how can we go ahead and actually solve this problem, right? So before we carry on much further, what I would like to do is just create a cluster that looks something vaguely like what our grid looks like. So I'm gonna, a cluster is just a placeholder, okay? And I'm going to place a couple of indicators, so let's call this 0. And I'm going to remove the indicators, increment and decrement numbers on this, just change that down. Number 1. And then let's do that, number 2, number 3, and number 4. Actually, let's just change the order of that a little bit so that it's in the right order that we see it. Oh, where am I going? Okay, and I don't want to see the labels for this, so I'm going to hide these labels. Can I hide these labels? Visible items, labels, there we go. So that's my top left, this is my top right. And this is my bottom right. Okay, so there we have our matrix of numbers that we want to see as answers, right?
Yeah.
What's going on now? Whoa, my remote desktop is not working very well. Let's just, there we go. So let's size that to fit. So this is our output. Okay. Have we done anything clever yet?
No.
This is a very slow coding challenge, isn't it? Well, shall I speed up, or would you still like me to explain as we go along?
Explain.
Okay, so let's see how this goes then. So we've got our numbers that we want to put in here as our results, right?
Yeah.
We know that by doing quick maths, we know that 2, 1, 3, 8 is kind of one of the set of numbers that gives us a good answer. Yeah. So let's have a think about this. What we want to do, like I mentioned before, is brute force. Put each one of these numbers in each one of the pockets,
yeah,
and then check if the combination of those equals to the sum of 100. Yeah, so we have another control in that case, which is either 100 or 200. So that's a sum that we are after, right?
Yeah.
Okay. So let's put that down as another control. Let's just copy that. This is our sum. And the number that should go in there is 100. Okay. Now, what I've just said of putting each number in there, the way we can do it with brute force is by something called nested for loops. Do you know what a nested for loop might mean?
No.
You don't know what a nested for loop might mean? Do you know what a nested for loop might mean, or you don't want to guess?
It might be where there's a bunch of for loops on one.
Inside each other?
Yeah.
Oh, okay,
So
like that.
Yeah, like that.
Nested inside each other.
Just do, I don't know how to say. Like if you, like that first one, if you told me to brush my teeth, then I would take 9 times. But then if it was a nested for loop, then the first 5 times, then it would do something.
So let's say, for example, in exactly that example, right? And let's take that as a use case. So if you had 9 times, so the left-hand side one as my outer for loop, or my inside for loop, whichever way, you nested that into another for loop which had 5 iterations. How many times would it run altogether? How many times would I have to tell you to brush your teeth altogether?
9 or less, I think.
So 9 times in one of the loops, and then a nested for loop with 5 times on it. So how many times is that?
14.
Is it 14?
Yeah.
Is it a sum with a nested for loop, or is it a multiplication with a nested for loop, do you think?
Sum.
No. It'd be a nested for loop would mean that you're doing something, the whole amount again. So if I'm telling you to do something 9 times, but I have to do that whole thing 5 times, it's a multiplication, isn't it?
Yeah.
So 5 times 9, how many times is that?
45 times.
What? That was quick. Quick maths. Well done. Right, so let's have a rethink of what we're actually trying to do. So because, I'm going to tell you something, because we're dealing with numbers, although it is numbers that we're dealing with, the one thing in our question that makes it a little bit tricky for me of deciding which way to go is, if you have a look at the question here, you have to make a 2-digit number reading across and reading down. Okay, so the easiest way for me to deal with that in programming is to convert it into something called a string or a character. Okay, so instead of adding 2 numbers up, you're joining them. Okay, does that make sense? So 2 and 2 make 4 when you add them, but when you put them together, it makes 22. So I'm going to do something like that. So I'm going to convert all of these into all of their numbers. I'm going to put them into as a decimal string. Okay, so let me just do that. Let me just make that bigger. So far, we've not done anything clever yet. We've just got a bunch of nested for loops, 4 of those. Now, I'm sure there always is a cleverer way of doing something, but I'm just going ahead and doing the brute force to solve just this one problem right now. Okay, so what we need to do is to go through each one of our numbers and put them into 4 pockets, don't we?
Okay.
So let me just see this. I'm not going to explain what I'm doing right now. I'll try and explain it as we go along slowly. So what I want to do is take each one of the numbers and put them into a pocket and see if the sum is a certain value. But before I do that, one of the things that your question has in the first line is choose 4 digits, each must be different.
Yeah.
So that's the first check I'm going to do, okay? So let's go back here. So I'm going to build an array out of the 4 numbers. I'm using the same 9 digits, so from our array there.
Yeah.
Okay, and I'm going to use the same 9 digits to build a smaller 4-dimensional array. Oh, I don't want to place that there. Okay, do that. So I'm going to take, in my nested for loop, what's happening now is every time I run this inside loop, what happens is you get 1 digit which was iterated first, 2nd digit which was iterated second, 3rd digit which was iterated third, and 4th digit. That might not make any sense right now. I can't explain it in less than 10 seconds for you to understand either. So the total number of iterations that this runs for. Have I lost you yet?
No.
Yeah, okay. That's interesting. I'm sure I've lost you. So the total number of iterations, like I said earlier, was 9 times 5 was 45, wasn't it?
Yeah.
In this case, you've got the outside loop, which runs for 9 times.
Yeah.
Inside that loop, it runs for another 9 times.
Yeah.
Inside that loop, it runs for another 9 times.
Yeah.
And inside that loop, it runs another 9 times. Now, I know you're good at mental arithmetic, but can you tell me what 9 times 9 times 9 times 9 is? Calculator. So 9 times 9 times 9 times 9. So there are a total of 6,561 combinations.
So how can a computer only choose one of those?
What do you mean?
How can a computer just choose one of 6,561 in less than a millisecond?
Oh, that's where the power of computing comes into play, right? And you know about binary numbers?
Yeah.
What is binary numbers?
Binary numbers are 0 and all of the numbers with zeros and ones, like 0, 1, 10, 11, 100, 101, 111, and 110.
Okay, so all the digits are in binary are just either zeros or ones. Is that right?
Yeah.
Cool. So what I've got here is, effectively, I've got a way of figuring out how we can go from 0 to 6,000.
6,500 something.
61 number of cycles, and every combination of the 4 digits is in those. That makes sense?
Yeah.
Now, in each of those combinations, what we need to make sure is, like the question says, each of them has to be different, right? So what I'm doing over here is I'm going, the way I want to do it is I want to build an array. So in the first iteration, it'll be 1, 1, 1, 1.
Yeah.
Yeah. And then I want to check, and I want to remove duplicates from that. So I only have 1.
Okay.
I need to check that the array size for that is a certain value. Now, for us, we want 4 different numbers, correct?
Yeah.
So, do you know what a case structure is?
No.
What would you know it as? Do you know what a condition is? If you do this, you get that.
Oh, yeah, I remember.
Yeah. So, this is a conditional case. So, if that array size that I've checked is of size 4, or where there's no duplicates, then I want to do something. Whereas if it's anything else, there are do nothing. So I don't want to do anything if they are the same numbers in my 4-digit array.
Okay.
Okay. I'll save that. So the first other question was, let's go back to our question one more time. The first part of our question was, choose 4 of these digits. Each one must be different. Put 1 in each box. And now we've got 4 digits, which hopefully should be unique. Okay. And we know that we're not going to do anything there. Now, out of the one thing that we created earlier, the output array, what I want to now do is put that into another array so that we get a whole bunch of results rather than just one result. Okay, so that now should have all the answers that will come out in a bit.
Can
I?
How many of these will you probably put?
We don't know how many we have as answers, do we?
I don't know either.
No, so we'll find out very soon. So I'm actually going to make that into an indicator. And change the indicator. I want to create a constant on there, and I want to start with a simple constant. Now, if I was to tell you the word shift register, what does it mean for you? Does it mean
register
anything?
that you get.
A
register for people.
Register for people. Oh, okay, like the register that you run at school in the morning.
Yeah. Or it could be like something with a bunch of shifts.
Shifts. Okay, what do you mean by a bunch of shifts?
A bunch of shift buttons.
A bunch of shift buttons.
Register all of them.
Okay.
I don't know what it means.
You might know what you mean, but I have no idea what you mean. So with a shift register, what it is a storage. So if I was to say, this is your box,
yeah,
put a value in it,
yeah,
come back and look at it later, it'll still be there.
So kind of like a safe.
Kind of like a safe. So here we go then. If we're saying there are not unique values, we want our safe to be as it was, right? We don't want our safe to change.
Yeah.
Okay. And we wire all those through. Now, well, one good thing about LabVIEW, and the one thing that's helped me learn LabVIEW well, is understanding that all the data that the computer stores is all in those wires. So each one of those has some value.
So it's literally building a gigantic hotel on each little floor. There's a little wire. Like that.
Okay.
Is it like that?
Sure. If that makes sense to you. It didn't make sense to me. I'm sure it makes it someone who's watching this later. So, okay, so what we've got here is if there are 4 unique values, we've got to do some extra calculations, but if they don't, then it doesn't do anything. So what I would like to do though is I just want to run this so I can not break that wire, and there it runs. Our sum is still there, so our sum is going to be imported in here, so I'm going to put that there. Okay, so you're with me so far? Mm-hmm. Okay, I'm very surprised, man. Right, so I'm going to try and hit Control U to see if that works out any better. Compact, yeah, that's okay actually. I'm going to use that. So let's do that. So I'm going to put some extra code here, some algorithm here to filter out if the sum of the 4 numbers that we care about is equal to 100, right?
Yeah.
So the first thing I'm going to do is to get from our short array, or the smaller array of 4 digits, all the elements in it. So there are 4 of them in there altogether. And what I want to do is concatenate, like your question says, 2 of those numbers together to make a 2-digit number rather than just a 1-digit number, right? So I'm going to take my first one and my second one, that's my first number, and my third one and my fourth one, that's my other 2 numbers. Then I'm going to take my first one and just, that's going to probably stay as it is, but oh no, there we go. From the first one and my third one, and I'm going to take my second one and my fourth one. And do you know what I've done just then? You can say no idea if you have no idea.
Crossing.
You have no idea,
Lines.
that's fine. Yeah, of course.
Lines.
So in one of our iterations, we have these numbers 2, 1, 3, and 8. Okay, so what I'm doing is out of those 4 numbers, which is what comes into our first part of this array here, okay, those are the 4 numbers that come in there. What we're trying to do is to combine those numbers to make 4 double-digit numbers, aren't we? So out of those 4 numbers, what we end up with is 21, yeah?
Yeah.
And 38 is our second number, yeah?
Then 23.
And then 23, yeah? And then
18.
18. So the way we got there is by taking our first digit with our second digit, yeah?
Yeah.
And then third digit with our fourth digit,
Yeah.
and then taking our first and third, 23, and second and fourth.
Yeah.
Okay, so you got those 4 in order, yeah?
Okay.
So what we did just here is out of that 4 numbers, we take the first one along with our second one, then second one with our, third one with our fourth one, and then first one with our third one, and what are the last 2? Second and
fourth.
Fourth, correct. Cool. So once we've done those, what I want to do then is to actually say I want to get the total of those numbers. Now, the sum of those numbers, yeah?
Okay.
So I'm just going to be lazy and build an array of those. Again, you hear the word array lots of times. There are different sizes of arrays here. And once I've got them into an array, I'm going to find a way to convert them back into numbers. Because right now they're strings, they're characters, aren't they? So decimal, string to number. I'm going to convert those. And I'm going to tell LabVIEW to also just give me a sum for all the numbers there. Okay.
Okay.
Now, what I'm checking for is the sum of that is equal to how much?
Is equal to sum of
the 4 digits, sorry, 4 numbers out of our 2 digits is equal to 100, first of all, aren't we? So what we do is, if that sum is, again, what is this one called again? The structure I've just put down? A case structure, right?
Yeah.
So if that is equal, then what that means is a match. If that is not equal, it means that the sum of the 4 numbers that we've just accumulated is not 100. Okay, so if it's not 100, what do?
We make it go all over again.
Yeah, we make it go all over again. So to our results, to our answer, we don't add anything to it, do we?
Yeah.
So we leave it as it is. Now, if it is correct that we've got those 4 numbers sum equals to 100, what do we do with them?
We take it as our answer.
We take it as our answer. So let me just see. One of the ways of doing that would be to just convert that into array. Now, I don't care about the joined up numbers like in our I'll say don't care. So here in this, I don't really care about 21, 38, 23, and 18. What I care about is 2, 1, 3, 8. Don't I? Because those are the numbers that go into our individual boxes.
Yeah.
Right there.
Daddy.
Mm-hmm.
I think we have to do that 200 one again.
Oh. Let's see if we can get 100 first.
Yeah.
But very good point. We'll get on to 200 in a minute. So far, we've managed to convert what we think is the right answer. We take the 4 digits rather than the combined numbers. Okay, and I want to convert that into an array. So let's just go ahead and convert array to cluster. And just move that across there. So my array that comes out of here, I'm gonna make that into a cluster because my cluster currently has got size of 4. I've got 4 digits.
Yep.
So I'm gonna convert that into a cluster and quite simply just build an array of that again. Now I'm completely confident that I've said array too many times for you to actually understand what is going on where. But I have maybe 25% confidence that this is going to work first time. I'm ready to run this and see if you get any answers. Do you want to try it?
Okay.
My logic kind of makes sense in my head at least. So we've got the 4 digits being combined, we're adding those, checking if it's 100, and if it is 100, we combine those up there. Let's run this and see what happens. Ooh, look! Oh, we got some answers.
Yay!
So we've got, let's split that a little bit. So we've got 1, 2, 4, 7, 1, 4, 2, 7, 2, 1, 3, 8, and 2, 3, 1, 8. Did we have, what was the answer?
Wait a minute. That's just swapping them two. The top right and the the bottom left.
Yeah, I know, right?
Yeah.
It's pretty cool. So they're reversible.
Yeah.
Nice.
Oh, that's my answer.
Which one?
3138.
2138.
Yeah, and
2138.
380. No, 18.
Yeah, that one and that one.
Yeah.
Awesome. Well, that's our coding challenge done then, isn't it?
Yeah.
Oh yeah, we got this. Right. So shall we leave it there?
200.
200? What do you mean 200? I thought we just completed it.
200.
200?
Yeah, make the 200.
Well, how do you think we're going to do that now, my Jenna?
Easy. Sum change to 200.
Is it that easy?
Yeah.
Alright, let's find out. Oh wow, we've got more answers. How many more answers have we got? Let's just visible items and change that to a scroll bar. We've got a few more answers.
Wait, count them.
How many is that in total? That's 22. Let me just put an indicator down for array size. It just gets a guesswork out of the way for you. All right, run that again. So 22. There we go. So you got 22 answers altogether with a 200.
Yeah.
And with 100, you have 4 answers.
Ooh.
So right now you've only checked 100, haven't you? As in, we've not done some with 200. So shall we try one with 200 and see if it actually does what it does?
Yeah.
So, like manually, let's bring up our calculator again. Which one shall we take, do you think? Let's take one of these ones. 7318.
Yeah.
The last one on the list. Okay. So what are the numbers that we've got? 73 and 71 and 38 and 71, 73, 18.
200!
Voila! I think that deserves a high five. Whee!
Oh, that's it.
Cool. Well, that's our coding challenge done. Well, that's our homework done at least.
Yeah, at least.
Did you do the homework?
Yeah.
No.
Yeah.
I did your homework for you.
No, I did.
Right, okay. So, well, thanks for coming on my coding challenge and being part of it. Did you learn anything today?
Yeah.
What did you learn?
How to make 100.
How to make 100?
Yeah.
Okay. Do you think you're going to use LabVIEW instead of
Scratch.
Scratch?
Yeah. I'm going to try something.
Oh, okay. Go ahead.
Where do you get stuff?
Where do you get stuff? Right click?
Okay, right click. I need the starter.
Oh, what?
The starter thingy.
Oh, so...
No.
A starter, so where your program starts running. Yeah. So if you see that top left arrow, if you go there, that one is what runs your program.
This one?
Yes. So everything on your block diagram is runnable code.
Oh, how do we put the starter thingy?
Oh, unlike Scratch, you don't need a starter thingy on here because there are different ways of handling the same event. So I think you're trying to think about what happens when you click on a button. Is that right?
Yeah.
Okay, so for that we have something called an event structure. So what do you think that icon is just now?
Like the starter thingy.
Okay, well you don't need to put a starter thing there, it'll just run it. So you can put numbers there if you want.
Okay.
The best way, select it. Can you select that? The best way to do that, I'm going to use quick drop. So Control space Control D, and it's going to put controls and indicators there for you. So you can see it's put controls with X and Y out front, and it's put an X plus Y indicator there.
So when I press this, it will probably add.
Yeah, but 0 add 0 is 0.
Oh, okay.
So you can change that.
How do I add?
Change your control.
Change my control.
On your front panel, yeah.
Where?
On your front panel on the right.
Oh.
You've got Y and X, right? So you can click on there and change that number to something else.
What?
Sure. 1 plus 1 is 2. Plus 1 is 3. Quick maths.
Okay. Yeah. So what will this be like? Let's see. There's nothing.
Well, you got 1 as X plus Y, can you see? So if you double click on that one over there, yeah, and put that into a number. That's 2. What do you mean nothing? Can I borrow your mouse? What's this here? So the things that you created just now were that one.
Ooh.
And these 2, right?
Yeah.
You got X and Y, are they?
Yeah.
So if you change that to a 10, what's going to happen when you run it? Any code on your block diagram runs, not just the part like where you have your start, like Scratch. Hang on.
Oopsies.
Don't worry. Control Z is your friend. You want to change that value, do you?
Yeah.
There you go. Does that mean you're going to come to me every time you want to solve your maths problems?
No.
Oh, okay, good. Is that what you're expecting?
Yeah.
You can't tell me that you did that in your head just now. Cool. All right. Well, I think you should pack it up then. Are you happy?
Yeah.
So that's your first session with LabVIEW, right? I know you've been asking for me to show you what LabVIEW is for a little while. Does that kind of show you what you want? Okay, I'm going to ask you now. What do you think LabVIEW is now?
Code. Coding.
LabVIEW just coding.
Yeah, a code.
Oh, okay.
You can make codes.
It's what?
Do you use that to debug stuff?
Yes, I use to program in it. I use LabVIEW to debug code.
How do you debug code?
And that's another session altogether, isn't it?
Oh, okay.
So there are a couple of ways you can do it. So in LabVIEW, you can do it by, let me go back to here. In LabVIEW, debugging is pretty straightforward. Let's say, for example, I'll press Control U there. That's your controls and indicators there, right?
Yeah.
Now, I can do something called a highlight execution, which shows me exactly what code is running. Now, if you have unlimited amount of time, you can sit here and wait for that to iterate through all of our for loops iterations there, but you can see on the bottom, you can see what values went in, what values came out already. So I can probe that and say, oh, I've not retained wire values. Let me just do that first. So if I run that now, you can see that wire has got that value of that much. And if I highlight execute, I can see it go through iteration by iteration. So one, almost like if you think about your Scratch, you can see what's happening one at a time. Yeah. 1, 2, 3.
Like move sideways, or like move forward one step, then spin around 50 degrees and say,
Cool. Well, next time maybe we'll do another coding challenge, and then not too soon though. I think I want you to go back to school if that's possible at some point.
Okay.
Cool. Thanks for coming, Jonah. Say thanks for everyone for watching, if they're watching. And anything else to add? Any other questions?
No.
Okay, well, that's been the coding challenge number 2. And thanks everyone for watching. And yeah, stay tuned for more.